Don't forget to subscribe and ring that bell.
Welcome back. We are on the final lap, the last leg, if you will, of the 2012 practice AP Calculus AB exam that College Board put out. Free response question 6. This is it. And bing bong, hello, no calculators allowed for these problems. That's fine, because on all of the problems that do not require a calculator or a calculator is not allowed, the algebra is doable. It's easier. Easier does not mean less work. Sometimes there's a rigorous amount of work there. It's just a rigorous amount of easy work. All right? Like, subscribe, you know the deal. Let's begin the end. Number 6 states, for t greater than or equal to 0, less than or equal to 12, a particle along the x-axis is moving. Say a particle moves along the x-axis. The velocity of the particle at time t is given by v of t equals cosine of pi over 6 times t. The particle is at position x equals -2 at time 0. That's where it starts. A asks us, for that interval between 0 and 12 inclusive, when is the particle moving left? First of all, y'all, when a particle is moving left, that means its velocity is negative or less than 0. Okay? I mean, it's just a negative value, its velocity. All right? So this is what we're looking for. Every time I think of that, I draw a number line with my critical points, or my derivative, or in this case, where my velocity is 0. And then I fill in the values in between, whether they're positive or negative. And that's exactly what I'm going to do here. All right? So first, let's create a number line, friends. Here, time would be on the bottom. Velocity is going to be on the top. Now, I don't know where my velocity is equal to 0 yet. Remember, velocity has to be 0 in order for a particle to change direction or to change sign, to go from positive to negative or negative to positive, okay? It needs to stop, all right? Because I am looking for some sort of interval when it's moving left. So we need to take our velocity and set it equal to 0 and see when it stops, okay? So velocity is cosine of pi over 6t. When is that equal to 0? That's where I'm going to begin. And to do that, I am absolutely going to go back to my, well, you can do the unit circle, I guess. But I am going to look at the graph, and I'll explain why in a moment. But you can use the unit circle or whatever. So let's look at the graph of cosine. All right? It goes as high as 1. That's a 1. Here's a 0. Here's a -1. Here's 0 on the x. Here's 90 or pi over 2. We're going to use radians. We always use radians in calculus. There's pi. There's 3 pi over 2. And there's 2 pi. Now, cosine is the cup. Starts up high, hits the middle, goes down low, comes back to the middle, and ends up high. And we connect that. Cosine is the cup. Bam, there you go. So where is cosine? Purple. No, this orange. Where is it equal to 0? Right here at pi over 2. And right here at 3 pi over 2. So what that tells me is this value in here, pi over 6 times t, needs to be pi over 2. And it also needs to be 3 pi over 2. So what am I going to do? I'm just going to take this value. Okay, I've got t times pi over 6 and set it equal to both of these. I'll get 2 answers, okay? So let's work with this one first. Pi over 2. Well, first of all, that's really 1 pi over 2. And if I want, the pi's cancel. I mean, I can really cross multiply here. You should realize right now that, well, 3 over 6 is going to equal 1/2. Well, let's cross multiply just for people who need to see it. 2 times t equals 6 times 1. So if 2t equals 6, there you go. My t is 3. Okay? So this happens at t equals 3, but there is another answer. I also need to take my t times pi over 6. Again, that's the middle thing here. And I need to set that equal to 3 pi over 2. And again, the pi's can just cancel right there. And we're going to cross multiply. 2 times t equals 6 times 3. So if 2t equals 18, and I divide both sides by 2, my t is 9. So at 3 and 9, this happens. My velocity is 0. So let's go to our number line. Here's 3. Here's 9. I know that my velocity is 0 at both of those points. But what about in between? I want to see which section of this number line my velocity is going to be negative versus positive. Well, here's another reason I like to look at the graph. Okay, in between, well, let's start this. Outside of my zeros, to the right and to the left, I have a positive output, a positive velocity. So outside my numbers, this way, it's going to be positive. Velocity is positive. In between, okay, let's go. Oh, yeah, we can use red. In between the zeros is where it's negative value, right? It's below the x-axis. So in between is when I have my negative values. Let's not forget when the particle is moving left, when my velocity is negative. Between these two values. Between these two values. So let's write that, okay? The particle is moving left when t is in the interval between 3 and 9. And that's it. B says, write, but do not evaluate. Oh, I love those ones. Write, but do not evaluate an integral expression that gives the total distance traveled by the particle from time t0 to time t equals 6. Now, I could do this in 2 seconds, and maybe you can too, but I'm going to explain why we get our answer. So it's going to take, slightly longer, but not that much longer. Let's go gray here. First of all, total distance. Velocity might be in feet per second. I don't even know if they give us in one particle moves along. No, they don't give us a time or a distance. But let's just assume we get a distance and a time. I'm just going to call it feet per second. Acceleration would be feet per second squared. Position would just be feet. This is my distance or displacement. Okay? Derivative this way, right? Guess what? Integral. If I have velocity and I want distance, I integrate velocity. So that's what we're going to do. We're going to set up our expression. Right? That's the first thing. So I'm going to integrate v of t dt from 0 to 6. Why 0 to 6? That's what they're asking. But there's one more thing here. There's one more thing here that I really want to highlight, and I'm not using a highlighter when I say that, and it kills me. Total distance. What's the difference between, total distance versus displacement? All right. Number line. Here, we're going to start at 1. Okay? I hate when the board does that. It's doing that lately. Here you go. We're going to start at 1. We got a particle that's going to start at 1. Then, it's going to go to 4. So it's going to go this way to 4. Okay? So our particle is 4. But then it comes back to 2. That movement right there. The displacement means How far is it from where it started? It started at 1, and it ended at 2. So it only went right 1, or it's positive 1. That's the displacement. Because displacement means this has to be negative, right? I went plus 3 to the right. That's how I went from 1 to 4. And then I went minus 2, because I went back to the left 2. I went from 4 to 2. Okay, so displacement means I got to consider positives and negatives when I combine. Total distance, not so much. The total distance means I went from 1 to 4, that's 3. And then I went from 4 to 2. I don't care what direction it is. I just went another 2 units. So I traveled a total of 5. Notice everything is positive when it comes to total distance. All right? Everything is positive. So are they asking us? Are they asking us for total distance? Or are they asking us for displacement? Right now, okay, this right here, any integration is displacement, area under the curve. If that area is above the x-axis, it's considered positive. If it's below the x-axis, it's considered negative. But they're asking total distance, which means anything should be positive. How do I represent that in an inequality, or excuse me, in a integration? I take the absolute value of my expression. That's total distance. And if you knew all this stuff, you could have just written that without any of these explanations. But for those of you that didn't get it, you need to hear it. Okay, you need to hear it. So we need the absolute value of velocity that we're going to integrate from our bounds from 0 to 6. And that's the correct response for B. C states, find the acceleration of the particle at time t. All right, so that's one thing they're asking us to do. Is the speed of the particle increasing, decreasing, or neither at time 4? Explain your reasoning. I love these types of questions. All right, because we love this, let's pick a nice color. I don't know if pink shows up too well. Let's do this nice soft blue. Oh, that's pretty. So I need to find acceleration. I'm going to go back to B. If I have velocity and I need acceleration, derivative. Okay? Derivative. So the derivative of velocity is acceleration. Okay? Or if you want to say the derivative of velocity, that would have been easier to write, is acceleration. So velocity is currently the cosine of pi over 6t. All right. We are going to have to do the chain rule. All right. Acceleration, which is the derivative of this, I take the derivative of the outside first. The derivative of cosine is negative sine. The inside stays the same, but then I multiply times the derivative of that inside, which would just be pi over 6. Okay? So let's clean this up a little bit, and let's put our constant out front. So acceleration is negative pi over 6 times the sine of pi over 6t. That's acceleration. So there we go. Boom. We did the first thing. Is the speed of the particle increasing, decreasing, or neither at time 4? All right. So speed increasing and decreasing, right? It's kind of a scalar representation. It's like multiplication, okay? And let me explain this right off here to the side in red. I need to look at velocity, and I need to look at acceleration. And then here's the speed. I'm going to just put SPD for speed. Okay, if the signs are the same, my speed will be increasing. So you see how it's like multiplication? If I multiply 2 positives, I get a positive. If I multiply 2 negatives, I still get a positive. But if they're different, and it doesn't matter which one's which, if they're different, my speed will be decreasing. So you see how it's like multiplication. Now, if velocity is 5 and acceleration is 2, don't tell me the speed is 10. Numerically, it's not at all like multiplication. I mean, maybe a little, but not at all. I'm just talking about whether it's increasing or decreasing. All right? And that's all they're asking. They're not asking us for the exact speed at that moment, but they're just asking us if it's increasing or decreasing. And that's how I'm going to do it. So I need to find velocity at 4, and I need to find acceleration at 4, and I need to see their signs. And then we're going to look at their signs. And that's going to tell me whether it's increasing or decreasing. All right? So we know velocity, that's this. And I know acceleration, well, we just figured that out. That's right. So let's do velocity at 4. That's the cosine of pi over 6 times 4. So I'll just put that 4 pi over 6. All right, let's reduce that. That's the cosine of 2 pi over 3. All right, well, 2 pi is 360 degrees. And if I take 360 degrees and divide it by 3, I get 120 degrees. Now, calculus always uses radians, but I like converting to degrees whenever I have to figure out an angle. That's just a mental thing that I like to do. So that's the same thing as saying the cosine, all right, of, 120 degrees. So I like to use the unit circle, not with all the labels and coordinates, but I like to use our right triangles, our 30, 60, 90 triangle and our 45, 45, 90 triangle. So in my unit circle, okay, in this unit circle right here, it does that all the time. No. Here's 180 degrees. Here's 90. 120, I don't know, it's probably right around here. I guess I should do this. Different color. That's 120 degrees. That makes a 30, 60, 90 triangle. And the sides are 1, radical 3, and 2. So from this angle here, cosine is adjacent over hypotenuse. Adjacent is 1, and hypotenuse is 2. So the cosine of 120 is 1/2, but remember, all students take cookies, we'll say. Sine is the only trig function that's positive in the second quadrant. This should be negative 1/2. Okay, so the cosine of 120 degrees is negative 1/2. I don't care about the 1/2, it's just negative. All right, so right now I'm going to go right here, negative 1/2. This is going to help me find whether the speed is increasing or decreasing. All right, not too shabby. We got to do the same thing for acceleration now. Ah, lordy. I think I tap too fast. Okay, so the acceleration at 4 is, looking at this right here, negative pi over 6 times the sine of, and that's still 4 pi over 6, which we just said is 120 degrees, right? So this is like the sine of 120 degrees times negative pi over 6. I'm going to go back to the triangle I just drew. I have 120 degrees here, but now I need the sine, which is opposite over hypotenuse. The opposite of 60 is radical 3. The hypotenuse is still 2. And sine is positive in that quadrant. Okay, it is positive in that quadrant. So that is, and we don't know a of 4 yet. Don't just put positive radical 3 over 2. This right here, that's a positive radical 3 over 2, still needs to be multiplied by a negative pi over 6. I mean, I guess if I can multiply those together, there's no need, but I can have negative radical 3 pi over 6 times 2 is 12. It's negative. Remember, anytime I multiply a negative times a positive, I'm going to get a negative answer. Negative radical 3 pi over 12. I almost said 6. Over 12. They are both negative. Look at that go. Oh, my God. So We finally answer the question. Again, a lot of easy work, but it's a lot of easy work. Okay, so we answer the acceleration. That's that box in the middle. Let's answer the next thing. Is the speed increasing, decreasing, or neither at time 4? And explain. Explain, kids. So let's write this final thing in blue here. Let's go back to our chart, though, quickly. They're both negative. This is the situation I have. So my speed is increasing. And I want to state that it's increasing. And I want to state why it's increasing. Okay, so speed is increasing at be specific, t equals 4, since both velocity at 4, don't just put v of t, is less than 0, or you can write is negative, and acceleration at 4, be specific, is also negative or less than 0. That is it. There are a million different ways you can write that, but we're done. Booyah. Last one. Find the position of the particle at time equals 4. All right. I hate to do this to you again, but we're going to go back to B again. We have velocity. We want position at 4, which means we're going to have to integrate to go backward. All right? Oh, glory be. So let's start. First, we need to find the equation for position. And then we want the position at time 4. We're going to plug a 4 into that t value. But first, we need the equation for position, which means we need to integrate our velocity, which was a cosine of pi over 6t dt. Do not forget the dummy variable. You can get points taken off. All right? I am going to u sub this to make it easy. Some of you guys that get quick at this might understand the reciprocal that you might have to use, but I don't want to confuse anybody. You really should get good at u sub if you're not good at it. I'm going to make u pi over 6t. So right now I've got the cosine of u. But now I need to find du. Okay, well, that's just pi over 6 dt. Problem is, I only have dt to sub for. So I want to get that alone. So I'm going to multiply both sides by 6 over pi. So they cancel. So now, in for dt is this. So I want du, but I also need 6 over pi. And since that's a constant, I'm going to put that outside of my integral. Now we can integrate. That is much more pleasant and much more easy to integrate. What do I take the derivative of that would give me cosine? Well, that's sine of u times 6 over pi. There are no bounds, so I have a plus c. How can I find, well, first of all, before I even ask you this next question, we got to get that u out of there. There are no bounds to put in. So whatever we took out and put a u in needs to go back in. So I have 6 over pi sine of pi over 6t. Now you can see what I'm talking about with the reciprocal there, plus c. If not, don't worry about it. You did use substitution successfully. Now, here's the thing. How do I throw a 4 in for t and I don't know the c? Oh my God. At time 0, its position is -2. That is a coordinate. I hate that they use x, and that value is really the y. And this is t. Okay, I really don't like it, so I'm just going to call it p for position. Why do they use x? Because the position on the x-axis is moving this way. Okay, that's the x-axis. All right, but its position is at 2, -2 at time 0. So let's go back. Boom, ba-doom, ba-doom. And I want to solve this at 0 for time, and position is -2. Okay, so this is equal to position now with respect to t. If this were a test, it would probably have to be x of t. I mean, it is a test, but you know what I'm saying. Anyways, All right, well, position is -2 equals 6 over pi sine of pi over 6 at time 0 plus c. I love multiplying anything times 0, because now I got 6 over pi. The sine of anything times 0 is 0 plus c equals -2. And now the sine of 0 is also 0. 0 times 6 over pi is 0. Don't forget, I'm still multiplying whatever the sine of 0 is times pi over 6. The sine of 0 is 0. I said 6 over pi. I don't know if I said pi over 6 there. But you're going to get 0. That will go right to 0. Love it. So -2 is my c value. This needs to go into my equation right here. Remember, this is the equation. For c, I got to put a -2. So I've got, we'll use x of t. 6 over pi, okay, times the sine of pi over 6 times t -2. I could have said plus a -2, but that's our c value. They want the position at time 4. Let's make sure I got that correct. Yes, that is correct. So now I've got 6 over pi times the sine of 4 pi over 6 -2. I could have swore we already did that. I could have swore we already did that. Okay? I think we already did that. We did for part C. The sine of 4 pi over 6, which is basically the sine of 120 degrees, was radical 3 over 2. So we already did this work, okay? So this is radical 3 over 2, which still needs to be multiplied by my 6 over pi. Then I need to subtract my 2, okay? Well, 2 goes into 6 3 times, so I've got 3 radical 3 over pi -2. Now, we don't have a calculator. They're not going to expect you to calculate pi in there, so leave it just like that. That is a numeric value, and that is my position at time 4. My goodness, what a wonderful exam that was. What a wonderful time I had spending it with you doing calculus. Thank you. Like, subscribe, and hey, leave a comment, because now I'm done with 2012 and I'm going to pick another test to do. If there's a test you want to see, put it in the comments and I'll try and get to it. So until we start another test, my friends, keep being math savvy, I guess. I don't know how else to sign off. I'll see you.
Don't forget to subscribe and ring that bell.